So, today we want to talk about graphing nonlinear functions. What in the world does that mean? Well, graphing, so I'm going to have to assume we're going to be doing some graphs, so you'll definitely need graph paper. Nonlinear functions. Now, this year, earlier in the year, we graphed lines, straight lines, remember? They had y-intercepts, they had slope, and we were just graphing straight lines. Today, I want to talk about a couple of equations that when you graph them, they're not straight lines, they're non-linear. And we're going to talk about two specific nonlinear functions. The first one is what we call the quadratic function, and it has a specific shape. And the second is called the absolute value function. And what you're going to find is both of these are things that you have done before. You have used them in equations before. They're both operations that you know how to do. We just never have graphed them before. Or you may have. I don't know. But we haven't this year so far. So the quadratic function, it is not going to graph as a straight line. What is the quadratic function? The quadratic function is a function in which the x is squared. Now, there can be other things in the equation. It can be 2x squared, or x squared plus 7, or 3x squared plus 2x plus 8. But the dead giveaway that makes it a quadratic function is that the highest power on x is 2. It is x squared. If you see x squared in the equation anywhere, it is a quadratic function. Well, if we know it's a quadratic function, if we know that x is squared, then we know what its graph is going to look like. Its graph is what we call a parabola, which is not a straight line. It's rather U-shaped. Not completely U-shaped. You will find that it does have a bottom to it. We call that bottom point a vertex. Now, the U can go straight up and down, or it can open downwards, or it can open upwards. It does go straight up and down, and it is symmetrical, so it's the same on both sides. But it can either be facing up or it can be facing down. The vertex is just always the bottom or top of that hump in it. But your graph is always going to look like this. And we'll talk about how we're going to get it in just a second. The absolute value function is any function in which the x is inside absolute value bars. Remember those straight bars? And if you recall, absolute value always means to take the positive of a number. It's the distance that number is from 0 is what it's measuring. So negative 5, the absolute value of that is 5. Positive 5, the absolute value of that is 5. It's always a positive number. All right? And so, again, you can have other stuff in there. You can have x plus 2 inside the absolute value bars. You could have absolute value of x and then have minus 2 outside the absolute value bars. You could have numbers multiplied in there. All that matters is that you see these absolute value bars. They're the dead giveaway that it is an absolute value function. Now, when you see that absolute value function, we know what the graph is going to look like. Very similar to the quadratic function, it turns around. You know, that quadratic function was a U-shape. The absolute value function, though, is a little straighter. It is a V-shape. It is not curved like the quadratic function. It is two straight lines, basically, that come together to make a V. It also has a vertex, that point where it turns around. Okay? And just like the quadratic one, it can go up or it can go down, depending on whether there's a negative in front of it or not. You know, if we multiply something by a negative, that always makes it negative, so it usually flips things over. So we know what the shapes are. This is important, guys, because when you're graphing things, you need to know whether you're doing it right or not. Because if you're plotting points on the graph and you get a shape that looks nothing like what you know the shape is supposed to look like, bells and whistles should go off. Something should go off in your head and say, wait a minute, wasn't this supposed to be a U? Why doesn't my graph look like a U? You know, you've got to have those kind of common sense warnings. So if you know it's a quadratic function, you know your graph should look like a parabola. And if you know it's an absolute value function, then you know your graph should look like a V. So make sure you have that kind of common sense thing going on there. But how do we actually get where the points go on the graph? So let's start with an example. Let's do the equation y is equal to x squared minus 6. Okay, and we want to graph this. For our purposes, what we want to do to get us started is to just make a table. Okay, we're going to make a table. We're going to pick some numbers for x to be. We're going to plug them in, and then we're going to get what y is supposed to be. Okay? So this is x squared minus 6. So let's say I chose negative 2, negative 1, 0, 1, and 2. So if I do negative 2 squared minus 6, negative 1 squared minus 6, 0 squared minus 6, 1 squared minus 6, and 2 squared minus 6. We're just going to plug them straight in. Negative 2 squared is 4. 4 minus 6 is negative 2. Negative 1 squared is 1. 1 minus 6 is negative 5. 0 squared minus 6 is negative 6. 1 squared minus 6 is negative 5. And 2 squared minus 6, let's see, 4 minus 6 is negative 2. Alright, one of the things that you're going to notice right away with quadratics, and the absolute value for that case, is that you're going to notice they start repeating themselves. Negative 2, negative 5, 6, negative 5, negative 2, 2 negative 5s, 2 negative 2s. This goes into that they're symmetrical. If you notice, we had a U. It was the same on both sides. It went up on both sides. Absolute value, we had a V. It was the same on both sides of that vertex. So what you see here is where it starts repeating, that number in the middle, that's our vertex. And then where it repeats on either side, that's where it's curving in either direction. So you always want to watch for where it repeats. Now I did this out longhand. You guys are very blessed to have graphing calculators. Your graphing calculator can do this for you. Now, be aware, yes, you can look at the graph on the graphing calculator, but that's not what's so powerful about the graphing calculator. You still have to put it on your paper, and the grid doesn't show up on your graphing calculator, and when things don't show up at an exact point, it's hard to see. So the graph itself is actually not terribly useful. The other thing is the screen isn't completely square, so it tends to make graphs look a little squished, and so they're not actually proportioned the way that they're supposed to be. So your graph isn't what's powerful. What's really powerful in that respect is if you look right above where it says graph, in yellow, it says table. The calculator can make the table for you. So where I just plugged all those numbers in and did it myself, the calculator would have done it for me. All I have to do is go to y equals, and then type in whatever the equation was that they gave me. In our case, it was x squared minus 6. So I'm going to hit x, that button with all the letters on it, x, and then squared minus 6. And so once I have the equation that I was given, instead of going to graph, I want to go to table. So I have to hit the second button, and then hit the graph button, and it's going to take me to a table. Now, when we make a table, we always want to have a couple of negative numbers and a couple of positive numbers. So you're going to want to you can scroll up and down just by hitting your arrows. So you want to scroll to a point where you have a few negative and a few positive, and you're also looking for where's that point where we actually repeat. Well, I see here negative 5, negative 2, negative 5, negative 2. We always want to pick some points on both sides of the vertex. We want to show where it repeats. And so this would have given us the table that we got, doing it longhand, but it will do it for us. I don't really care which method that you use to get your table, whether you plug it in yourself or you use your calculator to get that table, but you have to get a table. Now once you have your table, you just plot all of the points. So negative 2, negative 2, it's going to be right here. Negative 1, negative 5, it's going to be right here. 0, negative 6, it's going to be right here. 1, negative 5, and 2, negative 2. So notice that all these little points, they come in pairs. They have a partner. And then when you have those, you just draw your curve. Now you can always fit more points. If you make your table bigger, you can get more of the exact points to fill up your whole thing. Usually for absolute value or a parabola, you want to have at least 5 points. That gives you a good shape. Okay? So you want to have at least 5 points. The vertex always has to be one of those 5 points. But again, you want to make sure that you get enough points that you can see that it's nice and curved. And you want to remember that the parabola is a U. It's a curve. It's not a straight line. It should have some curve to it. But that's all we do. Make our table, plot our points, and get a U. It's the same thing for absolute value. Let's say that we have the following. Y is equal to 2 times the absolute value of x. Alright, 2 times the absolute value of x. So again, I'm going to need to make a chart. This time, I'm just going to use my calculator to make my chart. So if I go over here and I go to my calculator, I go back to y equals. Anytime you have something typed into y equals, all you have to do is hit clear, and it will clear out whatever you had typed there. The big deal here is we have to know how to do absolute value on the calculator. So I'm going to say 2 times, because when we have 2 in front of something, that means that it's 2 times that. And then to get to absolute value, you go to math, this math button, okay, and you go over to number. Okay, math and then number, and that very first choice is ABS, absolute value. Okay, now depending on the version of the calculator you have, my version is old, and so it says ABS in parentheses. If you have the newer version, it actually gives you the absolute value bars, which is really nice. You want to make sure that whatever is inside the absolute value bars in your equation is inside the parentheses, in my case, or the absolute value bars in yours. So x, and then I'm going to close the parentheses because that's going to close my absolute value bars. Okay, so 2 times the absolute value of x. Yet again, I don't want to look at the graph. I could. Here, we'll look at the graph. See? It's a V, just like we knew it would be because it was absolute value. But I actually need to get some of those points. And so I'm going to go to second and graph, and it's going to take me to the table. So again, I'm looking for where it repeats. 2, 2, 4, 4, 6, 6. So this looks like it's right in the middle here. It looks like my vertex is at 0, 0, which made sense because looking at the graph, it seemed to cross right there at 0, 0. So let's copy these down onto our sheet, onto our table. Alright, so it was 0, 0, and it was negative 1, 2, and 1, 2. And it was negative 2, and 4, and 2, and 4. And that should give me 5 points. So now I'm going to graph them. Negative 2, 4, negative 1, 2, 0, 0. And just like with quadratics, they should meet up. You know, they have little pairs. They're straight across from each other. Now, the difference between me drawing these points and drawing the other points, I know that the quadratic was a parabola, so I made it look like a U. I know that the absolute value is a V, so I have to draw it as a straight line. Okay? Notice it has a slope. It's following a pattern here. Up 2 over 1, up 2 over 1. It's going to continue that on through all of them. These are just straight lines. And so I can just draw my straight line, well, my kind of wiggly straight line, all the way up through those points, following that pattern, up 2 over 1, and I make a V. Again, I know it's supposed to look like a V, so I draw it like a V, but do notice that compared to my calculator picture looked a lot wider than this one. And again, it's because that screen is squished. And so again, the table is what is most useful on the calculator, not the graph function. But that's how we graph these nonlinear functions.